In this video, we're going to be finding a power of a complex number using DeMoivre's theorem. So the trigonometric form of a complex number can be used to raise a complex number to a power. So to accomplish this, we could consider using repeatedly the multiplication rule, but that takes a long time. And that's something that Abraham DeMoivre discovered. Now, Abraham DeMoivre is a very famous French mathematician. And he noticed a pattern and came up with this very beautiful formula that we're able to use right here. This is DeMoivre's theorem. So z to the n equals r to the n times the cosine of n theta plus I of sine of n theta. So let's go ahead and work out an example. So we're going to use DeMoivre's theorem to find 1 plus the square root of 3i raised to the 12th power. Now this right here, right now, is technically what we call polar form, but we're going to talk more about that in a future video. We want to turn this into trigonometric form. So we're going to go ahead and kind of move this up a little bit, give ourselves some room to work. So we're going to start off by graphing this. All right, so we have our imaginaries and we have our reals. And we're going to go over 1 and then up to radical 3. So here's our point. All right, so we want to find the r value here. So in order to find our r value, because we're going to need that for our theorem, we're going to go ahead and take the square root of our x and our y. And so we plug that in, we're going to get a square root of 4, which is 2. So we're going to have r equals 2. Now what about theta? Because in order to do this, we also need theta. So our theta is going to be, so we have our triangle here, right? And so we're looking for our theta. We're looking for our theta. And so we have a radical 3i, and we have our 1. And so we're looking for our opposite over our adjacent, or radical 3 over 1, which is, oh, well, I guess first we should talk about opposite over adjacent would be tangent, right? So the inverse tangent of radical 3 over 1, since we're looking for the angle, which tells us that theta equals the inverse tangent of the square root of 3. And if we look at our unit circle, we see that that tells us that theta is going to be happening at 60 degrees, or at pi over 3 if you were looking at radians. So for this particular example, I'm going to go ahead and I think I'm going to use degrees for this. So let's go ahead and we're going to find our z. So we're going to find our z first. So we're going to have z to the first power, so 2 times the cosine of our 60 degrees plus I times the sine of our 60 degrees. All right, so now let's find our z to the 12th. So our z to the 12th is going to give us a 2 to the 12th times the cosine of our 12 times our 60 plus I times, again, our 12 times our 60. All right, so the first thing I'm going to do is I'm going to multiply our 12 times 6. And so that's going to give me that 2 to the 12th times the cosine of 720 plus I times the sine of 720. So I can plug cosine of 720 and sine of 720 into my calculator, or I can also look on my unit circle and notice that 720 is coterminal with 360 degrees. So using that information, let's go ahead and move this up a little bit, allows me to say that the cosine of 720 degrees is 1, and the sine of 720 degrees is 0. So that leaves me with 2 to the 12th times 1 plus I times 0, and anything times 0 is 0, so that's going to kind of cancel that out. And so we're now going to be left with 2 to the 12th times 1, which is just going to be 2 to the 12th, right? Oops. Let's reverse that. 2 to the 12th. So here we're able to say when we plug that into our calculator that z to the 12th equals 4,096. And that is our final answer. And so that's how you can use DeMoivre's theorem to find the power of a complex number.